Welcome students, myself Dr. Mohit Saxena. In this lecture we would discuss distributions, particularly two type of distribution, Poisson distribution and normal distribution. Both of these distributions are very important to find out probability of a system or a discrete variables. In this particular lecture we would discuss these points: random variables, Poisson distribution and their properties, normal distributions and their properties. These are the points we would discuss in this particular lecture. But before going in the distribution, we just discuss about random variable. What are random variable? Random variable is a defined set of values with different probabilities. There are two types of random variable. First one is discrete random variable and second one is continuous random variable. That is, if we toss a coin, then this is a case of discrete random variable. And when we are selecting a student on basis of their height or age, then this is a case of continuous random variable. In discrete random variable, we would apply Poisson distribution when our sample size is big, and in this continuous random variable, we would apply normal distribution when our sample size is big or small. Now, first of all we will discuss first type of distribution, that is discrete distribution. Other examples of discrete distributions are binomial distribution and all, but in this particular lecture we would discuss normal distribution. In this lecture we would discuss Poisson distribution. Poisson distribution is a limiting case of binomial distribution. What is the difference between Poisson distribution and normal distribution? When our sample size is big, that is when n is large and value of p is small, that is probability of success is small, very small, almost approximate equals to 0. In this case we would apply Poisson distribution. The formula of normal distribution is formula of binomial distribution is NCR p to the power r q to the power n minus r, when n is very large and p is small. In this case, this distribution converted in the form of normal distribution, and formula of normal distribution is e to the power minus m to the power r upon factorial r. Here what is n? N is mean of the system or discrete variable. If this is mean, then standard deviation of the system is equals to under root of m. We will discuss it later on. But how this formula arrive from this normal distribution? Just listen. As we know, binomial distribution is equals to NCR p to the power q to the power n minus r, and q is equals to 1 minus p. When we apply this particular value here, and value of NCR is equals to factorial n upon factorial r factorial n minus r, we would get this formula. Now, case of Poisson distribution is a value of n is approaches to infinity. Now, there are certain terms factorial n, factorial r, factorial n minus r and so on. We take this m to the power r and factorial r, take outside of the bracket and find out limit of the rest thing. Now, this factorial n upon factorial n minus r, certain term will be cancelled out and we would get n minus 1 n minus r minus 1 upon n to the power r, and this and here n approaches to infinity. If we put limit on first bracket, limit on second bracket and limit on third bracket, that is n approaches to infinity, then this third bracket, second bracket and third bracket, this value limit 1 minus m upon n to the power n would be equals to e to the power m, and limit of these two factors are equals to 1. So, probability is equals to NCR p to the power r q to the power n minus r would become e to the power minus m to the power r upon factorial r. This is the basic formula of Poisson distribution and applicable in all cases where sample size is big and value of p, that is probability of success, is small. What are properties of Poisson distribution? They are simple properties of probability itself, that if any discrete probability space x p which possesses Poisson distribution, then probability of two sets, union of probability of two set, use this particular formula, just as simple and equivalent as the case of set theory. P of AUB is equals to PA plus PB minus P intersection B. Complement of probability of A is equals to 1 minus PA. This is this particular formula apply in many of the questions, and probability of A intersection B is equals to probability of A multiplied by probability of B. Certain other important formulas for Poisson distributions are as follows. Mean of Poisson, and this is a beauty of this particular distribution, that is why it is very applicable in most of the cases. What are the beauty? Mean of Poisson distribution as NP, and NP is equals to M. Variance, that is mu 2. Mu 2 is equals to, as we know, mu 2 is equals to NP minus Q. Here NP is equals to M and limit Q. If P is very small, then Q is almost equals to 1, and in this case mu 2, that is variance, is again equals to M. Mu 3, third one, is equals to Q minus P is 1, this is 1 and this is M, again M. Mu 4 is equals to this. So, the most important thing, mean and variance both of Poisson distributions are M, and skewness is equals to beta 1, beta 1 is equals to 1 upon M, and kurtosis is equals to 3 plus 1 upon N. Mean, variance, skewness and kurtosis, they are very simply calculated in the case of Poisson distribution. As mu 3 is positive, so Poisson distribution is positively skewed, and as beta 2 is greater than 3, so Poisson distribution would always be a leptokurtic type of distribution. Now, just understand this particular distribution by certain examples or problems. The first one is, birth in a hospital occur randomly at an average rate of 1.8 birth per hour. In an hour, 1.8 child born. What is the probability of the observing 4 births in a given hour at the hospital? So, per hour 1.8 child born, so M is equals to 1.8. If we know M is equals to 1.8, and in this case Poisson distribution can be applicable. So, we can very easily find out probability of observing 4 births in a given hour. Probability of borning 4 births in a given hour, we would apply formula P to the PR is equals to e to the power M, M to the power R upon factorial R. Here substitute M is equals to 1.8 and R is equals to 4. So, probability of 4 is equals to e to the power minus 1 by 8 into 1 by 8 to the power R upon factorial R. This is equals to 0.0723, that is 7.23% chances are there that in an hour 4 child born. Okay. Go to next question. This is the second case of previous question. If question is, in question 1, what is about the probability of observing more than or equals to 2 births in a given hour? What this question means, that what is the probability that in a particular hour more than 2 child born. Now, more than 2 child born means 2 child born, 3 child born, 4 child born in a given hour, and so on up to infinity. Of course, infinite is not possible in the case of hospital, but whatever the maximum limits are. Now, you have to find out value of these things, and by basic theorem of probability we know that P0 plus P1 plus P2 plus and so on is equals to 1. If this is equals to 1, then P2 and onward is equals to, the value of this is equals to 1 minus P0 minus P1. So, we have a formula, P is x greater than or equals to 2 is equals to 1 minus this is equals to 1 minus p x 0 and x 1, and x 0 we apply same formula, p to the power p r is equals to e to the power minus m to the power r upon factorial r. For first case r is equals to 0 and second case r is equals to 1. We simplify it, get the required probability p is equals to 0.537, that is there are 53% chances are there that more than 2 child born in a given hour. Okay. Next question. In a parking lot, on an average 2 car enters a certain parking lot per minute. 2 car enter in a certain parking lot per minute. What is the probability that during any given hour 4 or more cars enter in the lot? This question is rather similar to previous one. You have to find out P4 plus P5 plus P6 and so on, and value of this is equals to 1 minus P0 plus P1 plus P2 plus P3 bracket. Okay. So, you have to find out value of P0, P1, P2, P3. To understand normal distribution and cases of normal distribution, you must be comfortable in this particular formula. This is important. So, I take one more question on this type and evaluate value of P0, P1, P2, P3 and subtract this value from 1, because summation of all the probabilities is equals to 1. You would get point required probability PR is equals to 0.143, that is 14.3% chances are there that in a particular hour more than 4 car enter in a parking lot. Okay. Next one, the number of failure occurring in a machine of a certain type in a year has a Poisson distribution with a mean 4. In a particular factory, the failure of a machine having a mean of 0.4. In a factory there are tens of machine and that particular factory is using 10 such type of machine. Then what is the expected total number of failure? Expected total number of failure is equals to sample size multiplied by average of machine failure, that is 10 is the sample size, 10 machines are there and 0.4 is the average. So, 4 is the expectation. In last lecture we had discussed this thing in detail. In this particular expectation is equals to n times m. Second case, the probability that there are fewer than 2 machines fail in the factory, less than 2 machines fail. Less than 2 machines fails means no machine fail or 1 machine fail. Here we do not like to subtract from 1, and so just less than 2 machines fail in the year is P0 and P1. P0 is equals to the formula of Poisson distribution is still same, e to the power minus m to the power r upon factorial r. No machines fail, that is r is equals to 0, value this, and 1 machine fail, r is equals to 1. So, simplify it, we would get 0.0916, that is probability is approximately equals to 0.0916 is the chance that less than 2 machines fail. Okay. Now, move to next type of distribution, which is continuous distribution known as normal distribution. This is equally very important distribution. Normal function is equals to normal distribution function is equals to 1 upon sigma under root of 2 pi e to the power minus x minus mu minus 2 sigma square up to the whole square. This is normal distribution function, and this distribution, if we plot this particular function, we would get such type of curve. Now, this function is like this. Now, in normal distribution, we find out probability by area. How? Just listen this carefully. In this curve, there are certain properties. First property, that whatever our data is, mean, median, modes, all these 3 lie on the axis of this curve, number 1. Second point is this curve is symmetrical about its axis, that is shape and size on the left hand side is equals to shape and size on the right hand side of the curve, that is this axis just bisect this curve in a 2 part. and area represents probability. How we would discuss it later on, but area of this curve represent probability, and last but not least for this curve the total area of this curve is equals to 1 unit, the first property. Second, this is a distribution f x is equals to distribution function 1 upon sigma under root 2 pi e to the power minus x minus b to the whole square upon 2 sigma square. This is a normal distribution is defined by the above probability density function. Here mu is the mean, and sigma is the standard deviation. If we put these two things, then we take a new function variable over here, z is equals to x minus mu upon sigma, where x is the score, mu is the mean, and sigma is the standard deviation. Now, as mean median mode lie on this axis, so mu is equals to this one. Now, mu minus sigma, this is the point mu plus sigma, and this is the point mu minus sigma. Almost 60% area of this curve lie between the limit of mu minus sigma to mu plus sigma. 95% area, that is this particular area, lie between the boundaries between mu minus 2 sigma to mu plus 2 sigma, and almost 99% of the region bounded between mu minus 3 sigma to mu plus 3 sigma. Here sigma is the standard deviation and mu is the mean. For a system, for a particular example or case, if mean is fixed 50-50, okay, and sigma we take sigma is equals to 5, then mu minus 3 sigma is equals means that 50 minus 15, that is 35 this point, and mu plus 3 sigma is equals to 50 plus 15, that is 65 this point. If sigma is equals to 5, then we would get our normal curve like this. And if we increase the value of standard deviation, that is we increase it by 5 more units, there is now standard deviation is 10, then 50 minus 30 is equals to 20, and 50 plus 30 is equals to 80. Now, here our curve would be more flat type of curve. This is our theory of curve and analysis of curve, which is very important, and I hope you just understand the basic concept of this particular curve. Here what you like to focus for, you just have to focus on this particular formula of z only. Now, you have two options to find out probability in this particular case. The first one is this particular, you use, if you want to find out probability, you use this particular formula of integration for a particular x, just integrate this function and substitute limit to get out the value. Or you have one more option is use this normal table. This normal table is very important to find out the probability of any type of function. For normal table, just evaluate z. Z is equals to x minus mu upon sigma. You must know mu, you must know sigma, and you have a value of x. For a corresponding z, you would get value of probability from this table. If we take z is equals to 1.25, so 1.2 is here and corresponding 0.5 is this. This is 1.25. So, if you want to find out probability of any function whose value z is equals to 1.25, then from table it is equals to 0.3944. So, this is the probability. How it is represented in the curve? Z is equals to, this axis is known as z axis. Z is equals to 1.25, z is equals to 1.25 is this particular point, and here you must know, understand that total area of this curve is 1 unit. The curve is symmetrical, so 50% area is here and 50% area is here. So, this portion is equals to, numerical value is equals to 0.5. Now, corresponding z is equal value is 0.3944. So, the area of this blue portion Now it is almost red. This red portion area is equals to, this blue portion area is equals to 0.3944. Okay. If you want to solve questions on normal distribution, then you just practice this particular normal table. I take certain examples to find out different values and different type of cases. In first case, just try to understand. In an examination, mu is equals to 1500 and sigma is equals to 300. First point must be clear, mu and sigma must be given in the question. Otherwise, we have to evaluate that values also. In an examination, mu is equals to 1500 and sigma is equals to 300. Find the probability that candidate having at least 1630 score in examination, that is student get not less than 1630 marks. In other word, it also means that you have to find out the probability or chance that a student get more than 1630 marks, more than 1630 marks. Just try to understand. Here z is equals to x minus mu upon sigma. We know x, we know sigma. X minus mu upon sigma is equals to 0.43. Okay. Now, you get value of z is equals to 0.43, and from this normal table, if you try to find out, of course, this table is bit small for you to visualize. You can visualize a table by from your book or internet or Google, anywhere you just get this table very easily. Now, for z is equals to 0.43, if we see that this is the value, 0.1664 is the required probability. Now, what you had calculated so far and what you are supposed to calculate, you have to find out the probability that he will score more than 1630 marks, and here you get probability at z is equals to 0.43 is equals to 0.1664. Okay. Now, as this is a normal curve, just try to understand geometrically. Total area of this curve is equals to 1, 0.5 on the left hand side, 0.5 on the right hand side, and you had evaluated for z is equals to 0.43. Z is equals to 0.43 and you had evaluated 0.336. So, this is the shaded area which having probability or which having a value 0.1664. You had evaluated this, and what you are supposed to evaluate? You are supposed to evaluate that what is the chance he would get more than 1630 marks, that is his score must be like this. You have to find out value of this portion which is white one here, and this is equals to geometrically that this is the axis. If you subtract this region by this region, you would get your required region. This is equals to 0.5, this is equals to 0.1664. So, your required probability is 0.3336, that is 33% chance. What is the chance to get more than 1650 marks? If this is the case, so student get more than 1630 marks is 33.36%. Hope you understand this particular question. For better understanding, see in next question. In a class of 100 students, their mean height of a student is 70 inch and standard deviation is 3.3. Again, mean and standard deviation are given in this question. If Saurabh's height is at 82 percentile, find his height. You have to find out height of a Saurabh. Now, percentile means probability 0.8200 and 0.8200, that is this area is here probability is given. So, this whole area is equals to 0.8200 and how much this area is equals to? This area is equals to subtract 0.8200. Okay. Now, next is probability 0.8200 means 0.5 here and 0.32 here, this add up these two values, you would get 0.82, and this is 0.3200. For 0.3200, if you calculate, your value is equals to this much. Probability 0.3200 represent z is equals to 0.9200. You know z 0.9200, x, mu and sigma. So, you can very easily calculate value of x, which is equals to 73 inches or 6 feet 1 inch. This is a reverse calculation type of question. Next one is the mean noise level of a airport is 103 decibel. Okay. The standard deviation is 5.4. You have to find out the probability, the noise level of the airport between 100 to 110 decibel. Here two values are given. First of all, mean and sigma are given. Mean is equals to 103 and sigma is equals to 5.4. The minimum limit is 100 and maximum limit of our question is 110. For 100 value, value of z is equals to minus 0.56, and for x is equals to 110, we would get value 1.30. So, we get two values, one is z is equals to 0.56 and second one is z is equals to 1.30. From this table, z is equals to 0.56, we would get our value, and 1.30 we would get our value again, and their corresponding probability is 0.2123, 0.4032, means this area is equals to 2123 and this area is equals to 4032. Add up the both area, you would get your required probability. I hope you understand this case, and as well both distribution, normal and Poisson. They are very important type of distribution, and hope you understand both of them. Okay, beta. Thank you.